Hi, my name is Reese Hansen,
And I'm Ethan Waller.
and this lecture is going to be about mass spring damper systems.
So a simple representation of a mass spring damper system is a block, which would be the mass, resting on a smooth table with a force acting on it to the right, and then it's connected to a wall via a spring and a damper, and it has a force due to gravity acting on it as well as a normal force. A mass spring damper system can be represented by a block on a smooth surface connected to a wall via a spring and a damper with a force acting in the IX direction. So the spring force is equal to the negative of K times the displacement of the mass from the resting point of the spring, where K is the spring constant, which depends on the spring. The damping force is equal to the negative C x dot in the x direction, where C is the damping coefficient and x dot is the velocity of the mass. So the first step to solving a problem with a mass spring system is to draw a free body diagram, which includes all the forces that are acting on the block. So these forces include the force that's being applied to the right, which is a function of time, the force due to gravity, the normal force, the spring force, and the damping force, which both act to the left. And this is all in the IX-IY plane.
With the kinematics of the spring damper system, we have an initial position in the x and y direction, and you take the derivative of that in relative to time, and you get the velocity, and then you take the derivative of that, and you get acceleration. You plug the acceleration into Newton's second law, net force is equal to ma, and you get an equation with both x references and y references. You substitute a, the acceleration, in, and you separate the I and the x, or the y and the x variables, in order to get their own individual. You know that net y, or the force on the y, is equal to 0 due to y is equal to 0, and you know y double prime is equal to 0 also, and you end up with an equation, a differential equation of the mass spring damper system. So with the equation shown at the very end, you have an ordinary differential equation of all the variables divided by mass, and in that you have the spring constant and the dampener effect. Thank you for watching.